All right, good evening, grade sevens. I hope that you guys are all doing well and that you guys are keeping warm while we have this cold front blowing all over the place. Guys, welcome back to another lesson. This is now week 21 of tutoring. We're back for more work, it's no surprise. Just before we get started with today's lesson, I want to give everybody an opportunity to hop onto the live stream and join us, and then we will get started with today's work. All right. But just very quickly, while we wait for everyone to join us on the live stream, I want to point one or two things out to you very quickly, grade sevens. I do want to remind you guys that as we go into the holiday season in the next 2 or 3 weeks, that we will still have our we're still going to have our lessons as per usual. All right. So please don't think that when you go on holiday, all of the lessons stop as well, because I only see you once a week. We will continue with uh, lessons throughout the holidays. All right. So that's the first thing, guys. Number two, if you guys are comfortable with doing so, I would really appreciate it if you could type your names into the comment box for me. And I see that someone has already said, excuse me, that they need help with solving for x. Okay. So let me quickly take a look to see if that's something we can maybe cover in today's lesson, guys. Remember, while I do have a plan for what we want to be able to cover in each lesson, I'm always open to suggestions from you guys, because I'm here to try and help you guys with the topics that are frustrating you the most. Okay, as far as solving for X is concerned, that is not a topic that I believe we have covered so far this year. So I think that we can maybe spend a little bit of time looking at it today. All right. Um, Sorry, guys, just give me 1 second very quickly, please. Okay, guys, maybe we can take a look at this in fact. Right. So I'm going to quickly start by sharing my screen with you guys so that you can see everything that I can see. Just give me a second to do that, please. And then while I quickly double check something, guys, please make sure that you have all of your stationery and quickly write down today's date. I will give you a heading very shortly, but today's date is the 10th of June. Okay, sorry, guys. Something seems to be a bit weird. Sorry, guys. I just want to reset something quickly. Right. While we wait for this, guys, let's talk about this idea of solving for X. What in the world does it mean to solve for X, right? It seems like such a weird idea that letters that we use in maths like X, Y, Z, and so on and so forth can actually represent any number, right? Now, they do have specific um, values, but it depends on what's happening in the question. So on your screen now, you should be able to see my screen. I'm scribbling in a few different colored pens: white, yellow, orange, green, and even blue as well. It looks like I can see everything and that you guys should be able to see it too. So the date today is the 10th of June, 2025. Quickly write that down, and please make sure that you have all of the appropriate stationery that you need for today's lesson. So, when it comes to the world of algebra, grade sevens, there is a lot of information that we need to discuss. So I'm happy to start this topic today, but we will not be able to get through everything. But with that being said, if I start explaining the basics, this might help you guys to answer some of the questions that you have about the work that you're going through at the moment. I do apologize, guys. This grade over here is wrong. Let me just quickly adjust these times as well. So our heading for today is going to be the basics of algebra. That's what we're going to discuss in today's lesson. And hopefully this is going to give you an idea of what it really means to solve for x. Okay, the basics of algebra. So this is actually such a cool topic, grade sevens, and it's something you guys are going to use all the time in high school, not just once a week, almost every day. Okay, it's a very important topic. So let's quickly talk about what algebra is, and then we'll talk about some of the basics today. And if any of you guys have got specific questions, you're more than welcome to ask during the lesson now, but also if there's something you still want to know at the end of the lesson and I haven't quite had a chance to answer it for you, please ask me when we are ending the lesson, and then I'll try and help you out a little bit. Okay, so what is algebra, guys? Algebra is this world of maths that deals with all of these different letters, and we can have all kinds of numbers. And we really got to learn to first understand what in the world all of these letters are, right? How is it that I'm using X and Y and Z, right? What about the letter A? Where does that come from? What does that have to do with anything? So grade sixes, grade sevens. The way I like to describe the topic of algebra is as follows, guys. Algebra is the section of work that helps us to deal with more complicated missing number problems. So while we have all of these X's and Y's and equations and all sorts, let's go back a second. If I gave you something, a question like this, a square plus a square plus a square is equal to 12 Rand, right? And I ask you, what is the value of one square, right? What is a square equal to? I know that this must be 4 Rand. The next one must be 4 Rand. And the third one must also be 4 Rand. Why? Because 4 plus 4 plus 4 is going to give me the answer of 12, right? And you guys know all about these missing number problems. So instead of using pictures, grade sevens, we now start to use letters. So let's pretend I have an X plus an X plus an X, and this is all equal to 12 Rand, right? How much does each X need to be? In other words, what is the value of X? Now, there's a little bit of a misunderstanding when it comes to algebra, because people say, oh, X can be equal to anything that you want it to be equal to. But that doesn't make sense, right? What happens if I decided that I wanted X to be 100? 100 plus 100 plus 100 does not give me an answer of 12. It gives me an answer of 300 Rand, right? So that's definitely not right. So these letters that we use in algebra grade sevens are placeholders. You can think about them just like the shapes that we use in grade 5 and grade 6, even maybe a little bit in grade 7, right? Now, if I take let's go back to the first example quickly. If I take a square plus a square plus a square, do you not think that it's fair for me to say that 3 squares is equal to 12 rand? Right? 1 square plus 1 square plus 1 square gives me 3 squares. And we're allowed to do exactly the same thing with letters that we work with in algebra. Remember, these letters that we call variables are just used as a placeholder. You can even think about it like a question mark if you want to. So if I have an x plus an x plus an x, I can also say that 3x is equal to 12, right? We're applying exactly the same logic that we used even in the earlier grades of primary school, with the only difference being that instead of drawing pictures, we're now using letters. Why would we do that? Because as we go through high school, work gets a little bit more complicated over time. And I cannot draw a maths paper for all the scientists in the world to look at. And I have pictures of books and cars and bananas, right? It's not very professional. So instead of using pictures, we change to using these letters. Okay, that's the first thing I want you to understand. All these letters, it doesn't matter if it's an X or a Z or an A, it doesn't matter. These letters are just a placeholder. Okay. Number two, I really want you guys to keep in mind that when we work with algebra, these letters are a placeholder for a specific number, right? Not any number in the world, for a specific number. We just don't really know what that number is yet, right? So, what I want to do is write some notes very quickly, and I'm going to redraw this for you guys to copy if you haven't already. So, under today's heading, please write the following for me. Algebra is the more formal way of completing complicated missing number problems. Oops, sorry, complicated missing number problems, right? And we've been working with these missing number problems for quite a long time. This is not new to us, grade sixes or grade sevens, excuse me, guys. Right, that's the first thing we need to know. Number two, the next thing I want you to write down. Instead of using pictures, we now use letters called variables. And this is the first very important word that you guys need to become familiar with. What is a variable? It's a letter that represents an unknown number. So, yes, in one example, x could be 3, but in a completely different example, x could be 100, right? So, we call it a variable because the number that it represents can vary, it can change over time. All right. Don't stress about that too much. Just remember, instead of using pictures, we now use letters called variables to represent unknown numbers in a situation. Okay. Quickly write that down. If you guys have questions, please make sure that you ask. I will do my best to try and answer them for you. Right. Then you can write a little heading, right, for examples. And I want to show you guys how we make this change from working with pictures to working with variables, these letters. We're going to have version A and version B. Maybe you guys want to split your page down the middle by folding it in half. Right, you guys do not have to use the same colors as me here. You don't even have to use colors if you don't want to. Right. When you guys are done copying the information from above, you can start copying this example down. Right, so what I want to do now, grade sevens, is make a comparison. Everyone says that algebra is so confusing, but let's see if it really is that bad. On the left over here, we have example A. A square plus a square plus a square needs to equal 30 rand, right? Now, what we can actually do is practice breaking numbers up, right? So we can say that each square is 10 rand. 10 plus 10 plus 10 needs to give us 30, right? But the way we like to do this, especially when we work in high school, is to add things together, right? Now we have this idea called like and unlike terms, and we'll chat about this in a second. But when we have squares, we can put all of the squares together. If I have rectangles, I can put all of the rectangles together. But I cannot put squares and rectangles in the same group, right? I cannot put them together because they are not the same thing. But we'll talk about that in a second. A square plus a square plus a square gives me three squares. And I know that these three squares need to be equal to 30 rand, right? So how do I get one square on its own? Well, I can divide by 3 on both sides. Could I not, grade sevens? I could do that. If I divide by 3 on the left, 3 divided by 3 gives me 1 square, right? But whatever I do to the left-hand side of an equation, I must also do to the right-hand side. So 30 divided by 3 gives me our answer of 10 rand. I hope that that makes sense to everybody so far, right? Make sure that you are writing your steps down clearly, please, guys. Now, if we look at this, but we take this exactly the same example, but we now decide to change pictures into variables, right? These letters. Does it really change anything, guys? Well, let's see. If I have an x plus an x plus an x, right? X's are all the same. It's not like there's an X and a G and an H. There's three X's. And all three of these X's are a total of 30 Rand. So each X, I could break it up into into three pieces, right? And again, say that we have 10, 10, and 10. I see that there are one or two questions, guys. I'll answer them as soon as I'm done with this example. So what we can still do, like I said to you guys, is now add things that look the same together. A square plus a square plus a square gives me three squares. So an x plus an x plus an x, we should have no problem thinking that this gives us 3x. And all of a sudden, people see this and want to freak out. It's not that tricky, right? 3x means I have three of these unknown things. This 3x must still be equal to 30 Rand. So if I want to get x, if I'm being asked to solve for x, I don't want three of them, grade sevens. I just want one. So I can divide by 3 on the left because 3 divided by 3 gives me 1. So I just have 1x. Now, for now, you guys can write, sorry guys, you guys can write an imaginary 1 in front of this x, but we don't really write it down, right? Just like on the left over here, if I have 3 squares and I divide it by 3, I just have a square. I don't really say 1 square, but you can if you want to, right? But rather write it as an imaginary one. So 3 of these x's, if I divide it by 3, I just have 1x. And if I do exactly the same thing on the right-hand side, I divide by 3 on the right. 30 Rand divided by 3 also gives me 10 Rand. So the point of me doing this example with you, grade 7s, was to show you that this idea of algebra comes across as so scary and there's so many letters and everything seems really confusing and new, but it's actually just a grown-up way of dealing with missing number problems. Okay, that's what mathematicians do every day. Now, somebody's asked a question about when we are going to do BODMAS. First things first, we already did BODMAS this year. So at the end of the lesson, I will give you a date for the recording that you can go and watch because I unfortunately don't have time to teach it again. All right, but you can go watch the recording of the lesson for free and get everything you need. Then somebody's also asked if it needs to be in rands, right? Do we have to have things equal to rands? No, it could just be the number 100. It could be a fraction of 10 out of 100, right? It can be 1,000 different things. But for now, we just want to stick with it being nice and simple. All right. Okay, so I hope that this makes sense to you, grade sevens. I'll give you guys just 1 or 2 minutes to quickly copy, and then we're going to move on. Okay, while you copy that, we're going to look at another example, but I'm just going to make it a star, not question C, just a star. Okay. Now, what happens if I give you something like this? Or let's actually do this. Sorry, guys. Instead of a star, let's do C and D on the right-hand side. Let's say, for example, I have a question that I give to you, and I give you a square, but then I ask you to add on a rectangle, for example, right? Right. So now we have a square plus a rectangle, and let's say this is just equal to the number 100. On the right-hand side, we're just going to change these pictures into letters. Let's say I have A in yellow, and I make the green rectangle the letter B. Why would I do that? We'll talk about this in a second. If I look at this question over here, question C, grade sevens, what is the problem that we run into when looking at a question like this? If I have a square and a rectangle and they are equal to 100, how do I know what each shape is equal to? Remember, if it was two squares, it would be 50 and 50. But a square and a rectangle means that I have two different numbers. So do I maybe have 20 plus 80? What about 30 plus 70? What about 40 plus 60? What about uh, 90 plus 10? What about 99 plus 1? How do I know which answer out of all of these combinations is correct? Remember, when I have one shape and then a different shape, it means that these numbers are not the same. So we cannot assume that it's 50-50. Okay? I completely understand why you guys would want to think that. But that's not necessarily true, right? So we can have all kinds of different answers, right? All of these combinations add up to 100. 20 plus 80 gives me 100. 30 plus 70 gives me 100. So I run into a little bit of a problem because without any extra information, I cannot just sit there and say, you know what, today I feel like this answer. And somebody else decides, you know what, I feel like this answer. That's not how maths works, right? I know this sounds like a silly example, but can you imagine maybe working with NASA, right? You want to send spaceships to the moon or to Mars, and when you run into a problem like this, you just decide to guess. Can you imagine what that would do? It would cause a lot of problems. So, when we look at a question like this, guys, there, believe it or not, is no answer. So we would say that we do not have enough information to solve for the value of the square and the rectangle, right? And this is a real answer, guys. You are allowed to say not enough information, but this doesn't happen very often. Why? Because again, you can write these down as examples. 30 plus 70 gives me the 100, but 40 plus 60 also gives me 100, right? And there are so many other examples. We can say that we have 10 plus 90, like we said. This gives us 100, and so on and so forth. So when we look at a question like this on the right now, let's change these shapes into letters. We make the square A and the rectangle B, right? You could choose any letters. If you want to use S for square and R for rectangle, you're allowed to do that. But does this solve my problem, grade 7? When I look at this problem on the right-hand side, I still run into the same problem. I have two unknown numbers, right? And in maths, we only work with one unknown number at a time. So now we run into a tricky situation because, again, there is not enough information to solve this kind of question, right? And again, what would my reasoning behind this be? Well, A could be 30, just like we saw in the previous example, and B could be 70, right? We don't know what the answer is, but we don't have enough information to figure it out. What happens if I felt like B should have a value of 60? Then, sorry, A had a value of 60. Then B would have a value of 40, right? And all of these are possible answers, but we don't know which is the correct answer. Okay, I hope that makes some sense, grade sevens, right? 90 plus 10 is going to give me 100. So, what does this tell us about the world of solving for variables? We need to understand a concept called like unlike terms. Okay, so you can quickly finish copying this example, and then I want you to make a small heading for yourselves, please. Like and unlike terms. Okay. Now, we've chatted about the world of exponents before, um, grade sevens. So you guys should understand what the word base and exponent means, right? For example, if I have 2 to the power of 3, it's very important for us to remember that the number 2 is base and the number 3 is the exponent. So I would suggest you write a little note about this somewhere on the side of your page because it is going to be mentioned in our definitions for like and unlike terms. So, what are like and unlike terms, guys? Like terms is any set of, uh, we'll talk about the word terms now. Any sets of terms that has the same base and the same exponent. Okay. Number two, unlike terms. Right? And I like to use yellow for like terms because it's a positive thing when they are like. and orange for unlike terms because we don't really like unlike terms so much. Unlike terms is any set of terms that have different bases or different exponents. And this is a definition that you guys are even going to use a lot in grade 8 next year, grade 7s. So I would recommend that you write it down and please highlight the word or and like I've done on the screen. Now, why would we want to know about like and unlike terms? What in the world does this have to do with us finding these unknown numbers, right? Like X or Y or Z. Well, like and unlike terms tell us about how we can group things and how we may not group things. And again, you guys can make a small subheading for examples, or you can just write example A in the margin. It's up to you guys. I just don't have a margin. All right. Right. So example A. Please quickly copy these down and then I will explain them to you, grade 7s. Okay, please leave a little bit of space in between the two columns for me. Not too much, just a little bit. And please pay attention to the signs that you see in between the examples that I'm writing down. Right, I'm going to explain this now in a second, guys. Please just work with me over here. I promise this will make sense in a second. right, let's deal with these first six very quickly, grade sevens. Quickly copy these down and let's just discuss them very quickly. So I've given you two definitions, but some of this might not necessarily be making perfect sense just yet, and that's okay. So let's quickly talk about this. We understand now that algebra is essentially us learning how to work with grown up word problems, right? Missing number problems. So instead of using pictures, we just decide to use letters, right? But just in the way we can use different shapes or different pictures, we can also use different letters to help us, right? That's why we have a whole alphabet. So let's look at example A very quickly, guys. A plus, square plus a square plus a square plus a square. What kind of answer is that going to give us? Well, can I put these squares together? Can they be combined? Well, yes, in this case we can, right? If I give you one chocolate plus one chocolate, you would say to me, I have three chocolates, right? You group it together. So if I have a square plus a square plus a square plus a square, our answer for this is going to be four squares, right? And it works exactly the same way even when we're looking at algebra. If I have x plus x plus x plus x, I can combine all of these x's, right? Because they're all the same thing. And I want to just point something out, guys. X plus x plus x plus x would give me 4x. I cannot work in a question and say that x is equal to 1 now, and then 2 minutes later it's equal to the number 4, right? That's not how algebra works. So when we see an x, you can think of a chocolate bar, right? Or something that you want to think of. A chocolate bar plus a chocolate bar plus a chocolate bar plus a fourth chocolate bar would give me four chocolate bars, which is why the answer is X. So this is what we call like terms. Okay, and you can just write it on top, like above the question. These are like terms because they are things that we can add together, right? Now, if we look at the second example, the same thing applies even when we have to minus. Plussing and minusing lets us group stuff. A square plus a square plus a square gives us three squares. Minus a square would give us an answer of two squares, right? Think about it. If I had squares of paper, I give you one, I give you another one, I give you a third one, but then I take one away. Now I only have two of those squares of paper, right? And the same thing happens with X's or any other letter, right? Remember, I'm using X because it's the most common letter in algebra, but we can use A's and L's and Z's if we want to. But an X plus an X would give me two X's. Plus another one would give me three X's. Minus one means I would be left with just two X's. And again, these are what we call like terms, right? They are things that we can add together because they are all the same kind of thing. But in example number E, guys, a square plus a rectangle. Can any of you tell me what that's going to be equal to? Because I have no idea. Right? I know if I have a soccer ball plus a soccer ball, I get two soccer balls. If I have a hockey stick plus a hockey stick, I have two hockey sticks. But if I have a soccer ball plus a hockey stick, what does that give me? You can't add them together because they are two different things, right? They don't belong together. So we would actually say that this is not applicable. There's actually not an answer for this, right? And I want you to remember that this is an example of what we call unlike terms. And in the same way that we use different shapes, we run into different letters when working in algebra. So x plus y, right? What would that give us? I have no idea. I don't know what x is and I don't know what y is. But there is one thing that I do know for sure. X and Y are not the same thing. So we can't put them in the same group, right? So again, in this case, we would say that it's not applicable. There's no answer here. And this is an example of unlike terms. So if we come across this in a question, grade sevens, you might be thinking, what do I do? Right? What happens if I have a question where I have X plus Y? Well, you can't add them together. So unless there's something else you can do that you can see because of extra information, you actually can't go any further. Okay. So it's very important that we understand this idea of like and unlike terms. And I'm going to show you two more examples that get a little bit more tricky. And I'm going to explain how I decide if it's like or unlike using the definitions that we wrote down above. Let's say I had two, uh, two of the letter E plus three of the letter E. And on the right-hand side, I have 4F plus 2G. Right. You guys will need to go and brush up on your exponents if you do not feel super confident with it. But remember, when we are looking at a letter like this, like the letter E, and you don't see any little number sitting anywhere at the top over here, I want you to remember that that's because it's an imaginary one, right? It's an imaginary one. So we know that there's an imaginary one over here and an imaginary one over here, right? The same thing is true for F. It has an imaginary exponent of 1 because there's nothing else there. And the same thing for G. So remember, when we look at our definitions, guys, let's quickly zoom out a little bit and reread them. If we have like terms, it means that they have the same base and the same exponent, right? Over here, we have the same base, the number E and the number E. You don't worry about the numbers in front. But we also have the same exponents, right? So what can we say about this? Well, we have the same base in both of these values, and we also have the same exponent or power, right? For both, it's the number 1. So what does this tell us? These are like terms. Okay. Now, what about the example on the right over here? For f plus 2g, let's break it down. Do we have the same base? No, we do not. The base on the left is f, and the base on the right is g, right? Even though we have the same exponents of the number 1, f and g are not the same thing. It's like working with apples and oranges, right? You can't put them together. So we have different bases, but we have the same exponents. And unfortunately, unless both of them are the same, we have what is called unlike terms. So this is an example of unlike terms. I see that somebody's asking for the dates for BODMAS. I'll give that to you guys in just a second. I just want to finish this example. Okay, quickly copy this down. I hope that this makes sense so far. Okay, so guys, now that we understand that we know how to find like and unlike terms, let's just wrap up today's lesson by understanding why we need to know if we have like or unlike terms. Okay, on the left hand side, when I have like terms, it means that I can add things together, right? 2e plus 3e. Think about the letter E as a chocolate. 2 chocolates plus 3 chocolates is going to give me 5 chocolates. The answer is 5e, right? And that's completely fair. But let's think of F as chocolates and G as chips. Chocolates plus chips are not the same thing. We cannot add them together. So there's no answer. And this is why understanding like and unlike terms is so important. Okay. Because when we are given all of these complicated equations and we need to look for X and Y and A and B, we need to understand what we can group together and what we cannot group together. All right. So please quickly copy that down, guys, and then we are done for today. I just want to quickly find some dates, so please give me a second. And then I just want to quickly show you something on iRainbow. So the individual that was asking about BODMAS and BEDMAS and PEDMAS, you can go and look at the 28th of April. Okay. BODMAS, PEDMAS, BEDMAS, they're all the same thing. And you, like I said, can go and take a look at the 28th of April, which should be on YouTube and on Facebook. Then you can go and watch that lesson. All right. So grade sevens, that really is it, guys. That is all we have for today's lesson. Now, there is a lot to understand about the world of algebra in general. This is a topic that, like I said, becomes really important in high school, and you guys are going to use it very, very often. So, given that, unfortunately, guys, I cannot go through more today, but I hope that this does give you a good idea of what the world of algebra is all about. Okay, now I was quickly taking a look at some of the quizzes on iRainbow, and I think instead of doing one today, I'd rather have one more lesson with you guys to explain a little bit more about all of this algebra stuff, and then we can go ahead and look at some quizzes. Okay, so grade sevens, I really do hope that this lesson has helped a little bit, even if it just helps you to understand what the topic of algebra is about. All right. Unfortunately, I cannot do more in today's lesson, but if you guys come back next week for our next lesson, which will be on Tuesday afternoon again, hopefully from 5 o'clock until 6 o'clock, just like it was today, you will maybe get the opportunity to see more work on algebra. Okay, so I really hope you guys will join next week. In the meanwhile, guys, there are a lot of other lessons that we have covered this year. And like you can see, if you guys have questions about when we learn certain topics, you're more than welcome to ask. And I will then try and find dates for you so that you can go back and watch these recordings. Okay, remember, they are free for you guys to watch, and they are on YouTube and on Facebook. So you just need to go and take a look around and explore a little bit. Okay. So, guys, that's it for today. I really do hope that it helped. Nonetheless, I hope you guys have a great evening further. Please make sure that you stay warm, and that I definitely wish you guys the best of luck for any tests or exams you have coming up this week. Okay. If you think of any questions, please make sure to bring it to the beginning of next week's class. But until then, grade sevens, please look after yourselves, guys, and I will chat to you all then. All right. Thank you so much, grade sevens. I'll see you guys next week.